Hello again. We are going to do a review of multiplying and dividing fractions, and we're going to start with this, 8 times 5/4. Now, just so that you understand, 8 is the same exact thing as 8 over 1. It might be easier to look at this as 8 over 1 times 5 over 4. Now, you can multiply or divide fractions. You don't need common denominators like adding and subtracting. You just multiply the top with the top and the bottom with the bottom. So 8 times 5 is 40, and 4 times 1 is 4. Now, that's reducible. 40 divided by 4, you can take a 4 out of both, so we're dividing both of them by 4. And that's the same thing as 10 over 1, which is 10. Now, let's go back to this fraction. It's easier if you initially look at the fraction and as one big fraction. Now, anything on top can cancel with anything on the bottom. So you see how there's an 8 and a 4? You can cancel those. Take a 2 out of each of, or a 4 out of each of those. You could take a 2 out, and then you'd need to take another 2 out. But if you take a 4 out, this 4 becomes 1, and then 4 times what is 8? That's 2. So we know that 8 over 4 is 2. So now if you're looking at this problem right here, 2 times 5 is 10 over 1, and you're just left with 10. So 8 times 5/4 is 10. Now, if you remember what this means, 5/4 of 8, that's the same thing as 8 times 4/4 plus 8 times 1/4. So 4/4 plus 1/4 is 5/4. So 4/4 is just one whole. So 8 times 4/4 is 8. And then 8 times 1/4, we actually just did that right here. Because 8 divided by 4 is the same exact thing as 8 times 1/4. Same thing. So this is 2. So that's how it's 10. So because you're multiplying by a decimal a little bit more than 1, 5/4 is 1.25, then you're getting a number bigger than 8. So it's a good check when you're multiplying by a fraction to think if the fraction's bigger than 1, your number should be bigger. If the fraction's smaller than 1, your number should be smaller. So now that you had your quick review on multiplication, go ahead and try 10 times 1/5. Hit pause, and we'll come back together in just a second. So 10, again, is the same thing as 10 over 1. And 1/5 remains the 1/5. Now, you can just multiply across and then divide 10 over 5. Or you can reduce right here. Anything on top can reduce with anything on the bottom. It's like 10 times 1 over 1 times 5. So 10 over 5, you can divide a 5 out of both of those. So 5 out of 5 is 1, and 5 out of 10, 5 times what gives you 10 is 2. So this answer is 2 over 1, which is the same thing as 2. So if you look at it 10 times 1/5, you can also just think of it as 10 over 5, and you can divide that. 5 goes into 10 twice. So that's another way to get 2. So now let's think about 10 divided by 5. That's exactly what we just did, but we had it written as 10 times 1/5. So how is 10 divided by 5 related to 10 times 1/5? Well, anytime you are dividing by a fraction, you multiply by the reciprocal. So 5 doesn't look like a fraction, but 5 is 5 over 1. So I'm going to rewrite this as 10 over 1, and then divided by 5 over 1. Now that's like a fraction and a fraction. Looks kind of messy. So how about if we write it 10 over 1 divided by 5 over 1. So if you're looking right here, you want to get the denominator equal to 1 so that you can solve. So to get rid of this 5 over 1, you would multiply by 1/5 because 5 over 5 is 1. Now, whatever you do to the bottom, you also need to do to the top. So you're going to multiply that by 1/5. Again, the bottom, everything cancels and it became 1. In the top, we already know that's 2 because we just did that problem. So when you have something written like this, you can rewrite it as multiplying by the reciprocal. So when you're dividing by a fraction, instead of thinking of it like this big fraction that seems kind of scary to some people, you can multiply by the reciprocal. So every time there's divide by a fraction, we're going to multiply by the reciprocal. So again, this is 2 because we just did it a minute ago, but we're going to do a bunch now of dividing. So next up, our problem reads -4/5 divided by -8/15. So the very first step, again, this really is this really big fraction, like a fraction over a fraction, that looks a little bit daunting to work with. So instead of looking at it like that, which you can, we're just going to multiply by the reciprocal. So again, -4/5, and then instead of divide, we're going to multiply, but we're going to flip this. And the reason that we're flipping this is because if you were looking at it this way, to get this off the denominator, you would have to multiply by -15/8. And again, it doesn't matter. 15 over -8 is the same thing as -15 over +8. It's the same thing as a negative out front in a 15/8. One negative makes the whole thing negative. So that's what we're doing right here. We're multiplying by the reciprocal so that this whole bottom business is gone. So it's easier to work with. Whatever you do to the bottom, you do to the top. So that's why we're doing this. Now, in my brain, it's a lot easier, instead of doing 4 times 15, to reduce before we start multiplying. You don't have to do it that way. You could totally multiply across right now and then reduce second. But for me, I'm noticing that 4 and 8, they both have a 4 in common. So you can take a 4 out of that. This -4 will become a -1. And this -8 will become a -2. And then the 15 and the 5, they both have a 5 in common. So 5 out of 5 is just 1. And 15 is 3 times 5. So this is 3. So now we have -1 times 3. That's -3. Over 1 times -2, that's -2. Now, a negative over a negative is a positive, so this answer is just 3/2. You could write it as 1.5. It doesn't matter. That's up to you. I would try to stay away from decimals. It's easier as you get farther in math to use the fraction for more specific answers. If it's helpful, you could put this in the calculator, put that in the calculator, and make sure you have the same answer. That's a really great way to check yourself. By -9. Now, you might be thinking, well, what do I do? Because -9 is not a fraction. But you can make that a fraction. -9 is the same exact thing as -9/1. You can always do that. Every time you have a whole number, you can make it a fraction. So now you would just multiply by the reciprocal. So -3/4 times 1 over -9. So we could just multiply across right now, but it might be more helpful, again, to reduce anything on top with anything on the bottom. So 3 and 9 both have a 3 in common. So if you take a 3 out of -3, you're left with -1. And if you divide a 3 out of -9, you're left with -3. So now when we multiply across, -1 times 1 is -1, and 4 times -3 is -12. And a negative over a negative is a positive, so that's +1/12. And then you might just want to think, does that make sense? If you're doing 3/4 divided by 9, how many times does 9 go into 3/4? It's going to be a pretty small number. It's going to be less than 3/4. So that's why we're getting a small fraction. So makes sense. We have -4 divided by 9 and 1/4. Now, what do you think we would do here for our first step? I would recommend, but again, there's way more than one way to do this, making the -4 a fraction, and then writing this as an improper fraction. So again, you would do 4 times 9, which is 36, plus 1, which is 37. So we really have -4 over 1 divided by 37 divided by 4. You can check and make sure that you're right. 37 divided by 4, 4 times 9 is 36. You're left over with 1, so that's 9 and 1/4. So yep, we did that right. Now, instead of division, because it's that really big fraction, we're going to multiply by the reciprocal. So you're flipping the second one because this is what's on the denominator that we need to get up to the numerator. So this is 4 over 37. Typically, it's easiest to draw a line and reduce, but there's nothing that reduces here. So negative 4 times 4 is negative 16, and 1 times 37 is 37. Now, if you could reduce this by any number, that would be a really good idea. You want your fractions in the most reduced form, but in this case, nothing goes in to both 16 and 37, so that's your answer. All right, our next problem is 3 over 20 divided by negative 1/4. See if you can do this. Go ahead and hit pause and come right back when you're done. All right, so we're just going to multiply by the reciprocal. So 3 over 20 times negative 4 over 1. If you put the negative on the bottom, it's totally fine. There just needs to be one negative to make the fraction negative. It doesn't matter where it is. And then I'm going to go ahead and draw that big line. Anything on top reduces with anything on the bottom. 4 and 20 both have a 4 in common. So 4 goes into negative 4 negative once, and 4 goes into 25 times. 5 times 4 is 20. It might be helpful, I was just thinking about this, to rewrite 20 as 4 times 5, and to rewrite negative 4 as negative 1 times 4. And then you can see the 4 to cancel if you write out the prime factorization, or not even prime, just factors that are the same. All right, so left on top is 3 times negative 1, which is negative 3. And then left on the bottom is 5 times 1, which is 5. And this is not reducible anymore, so you're done. I have the next fun-filled problem. It is 9 over 14 divided by 15 over 28. Go ahead and hit pause. I'll give you just a minute. So hopefully you did 9 over 14 times 28 over 15. And this is nice because there's two things that reduce. So 9 and 15 both have a 3 in common. I'll go ahead and write it out like I said last time. 15 is 3 times 5 and 9 is 3 times 3. So we're going to cancel that 3 that they have in common. And then 28 and 14, 28 is 14 times 2. So you could rewrite 28 like that and completely cancel the 14s. If you saw a 2 in common, you could take a 2 out. So you have 28 over 14, and then you would have 14 over 7, and then you would see that there's a 7 in common, take the 7 out to get 2 over 1. So you don't have to take the biggest thing out first. You could take more than one thing out. All right, so left on top, you have 3 times 2, and that's 6. And left over on the bottom, you have 1 times 5, which is 5. And you might want to write that as 1 1/5. It depends what you're going to do next. I actually typically like to keep things in an improper fraction unless I'm completely done with the problem, because this is usually easier to work with for me. A lot of teachers make you write that in a mixed number. So just know that they're equivalent, and you just write down whatever works for you right now. Here's the next problem we get to do together. 4 1/2 divided by 1 1/2. Go ahead and hit pause. I think you can totally do this one. All right, so 4 1/2 we're going to write as an improper fraction. So 2 times 4 is 8 plus 1 is 9. So 4 1/2 is the same thing as 9/2. How'd that 4 come out of my hand? And then 1 1/2 is 2 times 1, which is 2, plus 1, which is 3. So that's 3/2. So we have 9/2 divided by 3/2. Every time you have a divide by a fraction, you're going to multiply that by the reciprocal. So 9/2 times 2/3. Now go ahead and reduce, or you could multiply, but 2 and 2 completely cancel, and 9 over 3 is the same as 3 over 1. You can think of 9 as 3 times 3 and cancel one of the 3's. That just looks confusing. Okay, so 3 is what's left on top, and 1 is what's left on the bottom. And 3 over 1 is the same exact thing as just plain old 3. Great work. You might again want to think, how many times does 1 1/2 go into 4 1/2? It is actually kind of an easy number to figure out. 1 1/2 like $1.50 If you have 2 of those, you have $3, 1.5 plus 1.5. And if you have another 1.5, that's 4.5. So 1.5 goes into 4.5, 3 perfect times. Next up, 5 divided by 5/7. You totally have this. Good luck. All right, hopefully you made the 5 over 1. And then you change that division to a multiplication and you made this the reciprocal. And then you're noticing that there's a 5 on top and a 5 on the bottom. So cross that 5 off. So you're left over with 7 on top and 1 on the bottom. So 5/7 goes into 5 more than 5 times. 5/7 is a smaller number than 1. So if you're dividing by a smaller number than 1, this should be a bigger number than it is. So 7 is your answer. Because 1 goes into 5 times. So a number less than 1 will go into 5 more than 5 times. Okay, this will be the grand finale problem. -5/6 divided by 1 2/3. So go ahead and hit pause because I know you can do this. Hopefully the first step that you did was make this an improper fraction. So 3 times 1 is 3 plus 2 is 5. So this is also 5/3. So we don't need to look at the 1 2/3 anymore. This is 5/6 divided by 5/3. So then you're multiplying by the reciprocal, and the reciprocal is 3/5. And then those things cancel. Just really don't lose that negative. Watch that negative. When you cancel the 5s, you're still left with a -1 because -5 is -1 times 5, if you can see that. Eek. Okay, so -1 times, well, hold on, 3 and 6 are cancelable also. So there's a 3 that can come out of both of these. So the 3 would be a 1 and the 6 would be a 2 because 2 times 3 is 6, so the 3's cancel. All right, so -1 times 1 is -1, and 2 times 1 is 2, so 1/2. So -5/6 divided by 1 2/3. If you're dividing by a number that's more than 1, this is going to be smaller. It's going to go in at less times than that number is. So -1/2 is a smaller number than -5/6. Well, I guess it's not really a smaller number because if you think of it, I'm thinking of it in the positive world, but if this is 0, this is -1/2. So that would be 3, 6, 4, 6. This is 1. This would be -5/6. So if I was talking money, I'd rather be -1/2 in the whole than -5/6 in the whole because that's actually a bigger number because it's negative. But if you're just looking at it in decimal form, 1/2 is 0.5. Get a pie, that would be half of it shaded. And this, if you were to look at a pie broken into 6 pieces, it would be 5/6 of it shaded. So this is a bigger number in general. It's more negative. In the positive, it's also a bigger number. So if you're dividing 5/6 by a number that's more than 1, which is what you're doing, you should get a number, just think positive in the numbers, you should get a shading that is smaller. Because again, this would be a little less if you're talking how much money you have, but if you're looking at the shadings, it's smaller. So it's all relative. Well, hopefully that ended on a good note for you. The next video is going to be on solving equations with these fractions, solving for a letter. So have a great day.